Everyone knows this moment. You're standing in a crowded boarding gate. Your group is called, but nothing really happens. People stand. Bags collide. Someone blocks the aisle. The line stops. Starts. Stops again. And the question almost everyone has asked at some point is, why is this still so bad? Because surely, with all the data airlines have, there must be a better way. The short answer is, there is. The long answer is why it almost never gets used. From a purely mathematical perspective, boarding an aircraft is a solved problem. Researchers have tested dozens of boarding methods, back to front, window seats first, outside in, random boarding, even complex seat order algorithms. In controlled simulations, some of these methods board planes 30 to 50% faster than what airlines use today. So why don't airlines use them? Because boarding a plane isn't just a math problem, it's a human systems problem. Most people assume boarding is slow because the aisle is narrow, there isn't enough overhead bin space, but those aren't the real constraints. The biggest delay comes from seat interference. That's when someone already seated has to stand up, move into the aisle, or let another passenger pass. Each interference can cost 5 to 15 seconds. Multiply that by dozens of passengers, and delays stack up fast. The most efficient systems minimize seat interference, which is exactly what airlines don't optimize for. So here's the paradox. Airlines know faster boarding methods exist. They've tested them, they've read the research, but they rarely use them. Why? 1. Passengers don't follow complex instructions. If you tell people, row 27 window seats first, then row 26 aisle seats, most will simply ignore it. Confusion causes hesitation. Hesitation causes delays. 2. Families and groups break the model. Most boarding algorithms assume solo passengers. Real flights don't work like that. Parents want to sit with kids, couples want to board together, airlines design for predictability, not perfection. 3. Gate agents can't enforce precision. A perfect boarding system only works if everyone complies and staff strictly enforce it. That's unrealistic in a busy terminal with tight turnaround times. Boarding zones aren't designed to be optimal. They're designed to be manageable, reduce crowding at the gate, give the appearance of order, are easy to explain and enforce. They're not the fastest, but they're the least chaotic. From the airline's perspective, chaos costs more than inefficiency. Here's something airlines rarely say out loud. Boarding inefficiency helps them sell priority boarding. Early boarding guarantees overhead bin space, reduces stress, and feels valuable. If boarding were perfectly efficient and evenly spaced, priority boarding would be much harder to sell. In other words, some inefficiency is profitable. A few tried to fix the problem. Some experimented with window middle aisle boarding, strict back-to-front boarding, and random boarding trials. The results? Slight time savings but more passenger complaints. In most cases, airlines reverted back because shaving 2 minutes off boarding isn't worth annoying hundreds of passengers. From an airline's perspective, boarding doesn't have to be fast, it has to be predictable. Schedules, crew rotations, gate availability, and runway slots all depend on knowing roughly how long boarding will take. A theoretically faster system that sometimes causes confusion or delays is riskier than a slower system that behaves the same way every time. In that sense, boarding inefficiency isn't a failure. It's a trade-off airlines have deliberately accepted. Plane boarding feels inefficient because it is, but not because airlines don't know better, but because the system is balancing different factors such as human behavior, operational simplicity, staff workload, and passenger perception. The goal isn't the fastest boarding possible, it's the least bad boarding experience that still gets the plane out on time.